All right, kiddos, when you go in to do your pedigree practice, we're going to access this file a little bit differently because it's a PDF. So go ahead and click on the link, and you should see something like this, and there's a little arrow in the corner there that says download. Click download, and then go ahead and throw it right on your desktop. That's fine. It's the easiest place to find it. And then you're going to close this and go to your desktop, and you should see the PDF file. But what you want to do then is right click, and then you are going to do open with, and you want Adobe Acrobat. So open with Adobe. And what we'll be able to do now that we're in Adobe is this fill in sign, which will allow us to, oh my goodness, go away, write on this paper. So we're going to be looking at our pedigrees from lecture, and we said that there are different kinds of ways that things could be inherited in pedigrees. You could have autosomal inheritance, which is just, it's on a regular body chromosome, and it's either recessive or dominant. If it's recessive, very few people are going to have it, okay? And two affected parents cannot have an unaffected child, okay? So if it's recessive. If it's dominant, many of them are going to have it. Every generation will have affected individuals. Then there's sex-linked. These are the ones on your sex chromosomes. And all of them are recessive. You only have that choice. But the biggest thing with sex-linked is it shows up way, way more in males. All right, so you see a significant difference in males and females. So on your paper, you're going to go along with me. And we're going to figure out what kind of inheritance these four are. So looking at the first one, if you click fill in sign, and then you can kind of make a little box here, and that's where we'll type our answers. So if you look at this one, the affected individuals are the colored in ones, which are down here at the bottom. So if I move that for you, down here at the bottom. As we look at it, circles are females, squares are males, only one of each. So this isn't predominantly males, so it's not going to be sex-linked. And it doesn't show up every generation, so it's not going to be dominant. So what this one is going to be is autosomal recessive, okay? Very few of them have it, and those that do are not in every generation, and you don't preference boys. Now over here at C, I'm just going across, you'll notice the three individuals that have it, not every generation has it, so it's not dominant, but the three that have it are all squares, which are all boys. And so the inheritance that is mostly males is sex-linked. And we're going to scroll down. All right, if we look at this one, only one individual has it, and that individual is a circle, which is a female. So this one is also autosomal recessive. Okay. And then we got this one. If you look at this one, there is a little bit more males than there are females. But more importantly, every single generation has the disorder. So when every single generation has the disorder, this is going to be autosomal dominant. All right, shows up a lot in those generations. All right, so we have a pedigree down here. It says below is a pedigree for an inherited lung disease. Provide the genotypes of each of the individuals marked with lowercase. So first we need to figure out what kind of dominance is this. So if we look at the pedigree, you'll notice that it doesn't show up more in boys than girls, so it's not sex-linked. It does show up in almost every generation. This is the same generation. So every generation it shows up, sorry. And because it shows up every generation, it's probably dominant. So if it's dominant, we can pick a letter. Let's do big L's for lung disease. So big L is lung disease, and little l is normal. So that means that anybody who is colored in, right away if they're colored in, they must have at least one big L. We know that because they have the lung disease. So we're just going to make little things next to all of these guys here and put an L there. All right. And all these other guys that are not colored in, they are normal, and normal is recessive. So in order to be recessive, they have to have two little L's. So all these non-colored in guys, we know right away that they are two lowercase L's. And so we're going to label all of them, which is annoying, but that's how it's done. Come here. All right, let me not forget these guys. And down here as well. All right, I think I got everybody. So now we have to try to figure out the ones that are missing. So this parent up here at the top that has one big L. Is this possible? In order to have all these recessive kids, what must his other letter be? Because they have two little L's. One came from mom. Where did the other one have to come from? It had to come from dad. So dad has to have a little L in order to make these kids. Okay? Now we look at mom over here. We got the same kind of situation. Some of their kids are little L, little L. In order to be little L, they had to get one from dad, and the other one had to come from mom. So mom is also big L, little L, or heterozygous. All right, down here, these two girls came from these two parents. They had to get the big L from mom. So what did they get from dad? They had to get a little L from dad. So they're also heterozygous. Down here at the bottom, we got two kids that are little L, which makes sense because the two parents are little L. But then look at this kid down here. This kid down here, if this is dominant, right, somehow has a big L. And could that really occur? So this one must have been a mutation, okay? That could not happen. So there was something weird going on. Either this is not their biological child, or they got the wrong child. It's not possible because they would have to be little L coming from those parents if this is a dominant trait. All right, below is a pedigree. I got to shrink this down a little bit. Below is a pedigree for an inherited brain disease. Provide the genotypes of each individual marked with lowercase letters. Okay, so again, we're going to do the whole thing. If we look at this, this generation has it, this generation has it, and there's one in this generation. So it doesn't show up more in boys. So this is also another dominant one. So it's a brain disease. So let's do big B is brain disease. And then little b is normal. So once again, everybody who's colored in must have one big B in order to have the brain disease. So we're going to give them all one big B. I got one left. And that means all these guys that are not colored in must be normal, and they're going to have two little b's. And so basically what we're doing when we do these things is we're doing like the Punnett square in our head, more or less. Let me put this one right here. Put this one right here. And I really enjoy these because they're like a little puzzle. All right, I think I got everybody. So now we're going to try to figure out some of these people, especially these ones they said with the letters next to them. So let's look at this dad right now. So this dad has 4 kids, but 2 of them have little b's. One came from mom, the other one had to come from, you guessed it, dad. Now these 2 kids, they got their big B from dad. What did they have to get from mom? Little b's, right? You notice a lot of them are heterozygous because that's the only way you get these recessive ones to pop up. All right, over here, these guys have 5 kids. 1, 2, 3, 4, 5. 2 of them are little b. Well, they had to get one of those little b's from mom and one from dad. So that figures both of these guys out that they must be big B, little b. That one went a little wonky. Okay. Now, here's a conundrum, though. These daughters down here, especially these ones that aren't married and don't have kids, we know they have a big B. The big B could have came from dad or mom. Do we necessarily know their other letter? They could be big B, or big B, little b, and still have a brain disease. And we have no kids to look at. So when we don't know for sure, you just kind of put a dash there instead, because we're not sure what their other letter is. We can't figure it out from the pedigree. All right, so this parent, it's going to be the same thing because their kid got a big B from them. We don't know if they're big B, or big B, little b. But their kid we can tell because the big B came from them. What they have to get from dad? They had to get a little b. So sometimes you just can't tell. All right, and then that's everybody. So we're not going to do the rest of this sheet. I just wanted to show you kind of how you go around and do the pedigrees. So fill in your sheet this far and then save it and turn it in, and I'll give you some points for doing it along with me. Bye.